my name is Sarah and we're going to be talking about forces acting on an airplane while we're in a turn. So essentially a turn is the change in lift vectors, and so we did have solely vertical lift, but now that we're turning we also have horizontal lift acting on the aircraft, and so these two components of lift give us a total lift vector. And so depending on our bank angle, which could be shallow at 20 degrees, medium at 20 to 45 degrees, or steep at greater than 45 degrees, this vector is going to shift because we will have a greater horizontal lift than vertical lift with the greater the bank angle. And so whenever we have a greater horizontal component of lift, we have to add back pressure to help our vertical component of lift in order to have a greater total lift acting on the aircraft, because we have a centripetal force that is pulling us in towards the center of our turn, and then we also have a counteracting centrifugal force that is pulling us away from the center of our turn. And so when we are turning, in the case that we do want to roll out, you want to make sure that you roll out half the degrees of your bank angle from your intended heading. So if we were turning at 30 degrees bank, then we would want to roll out 15 degrees before our intended heading. Now, because we have this horizontal component of lift pulling us in, and we have that centrifugal force pulling us out, counteracting that, we have what's called load factor acting on the aircraft, which is the ratio of the total lift and the total weight of the aircraft. So we have this total lift vector, and so we will have our load factor counteracting that. And so for example, if we are in a 60 degree angle of bank and we are at our max weight, then we will have our max weight of horizontal component of lift and vertical lift, and then we have our actual weight of the max weight pulling down on us. So our total lift will be combined, and then we will divide that by our actual weight of our aircraft. And so in this case, that would give us 2 G's, which is a unit of gravity that we use to describe the load factor acting on the aircraft. And so we can use this to find our stall speed when we are in a turn. And in this case, with a 60 degree angle bank, we would take the square root of our load factor and multiply it by our stall speed to give us our stall speed in the turn, which would be 68 knots. So it's really important to consider your load factor when you are in a turn, because that is also going to change your stall speed. So these are some of the components that are acting on your aircraft while you're in a turn. Thank you.